Good morning, ladies and gentlemen. As I promised my class, I'm going to work through Test 2, version 1 of RBA. This is the test that Management RBA wrote. So let's work through it. The first question, simple rounding question. It says round 74,736,836 to the nearest million. So when you're doing rounding, the first thing you need to do is you need to know that this number 6 represents units, tens, hundreds, thousands, 10,000s, 100,000s, and then millions. So you need to know what each number actually represents, and it says here round this off to the nearest million. So we identify that the 4 represents millions. So what we do once we've found the right unit or number, and this one is rounding off to millions, we look to the number to the right, and if it's 5 or bigger, we round off to a unit bigger. So here we have a 7, which is 5 or bigger, so the 4 becomes a 5, and then all those numbers to the right which hold places become a 0. So if we round this number 74,736,836 to the nearest million, we get 75 million. This takes a bit of practice, but very important is identifying the unit and what each number represents. Ones, tens, hundreds, thousands, 10,000s, 100,000s, and then millions. So the 4 represents millions, and then we can take it from there. So it's 75 million. The answer is C, 75 million. Right, let's go on. Round 124,6775 to the nearest hundredth. So we've got tens, and then we've got the 6 here represents tenths, the 7 is hundredths, the next 7 is thousands, and the 5 is 10,000s. So they want you to round off to the hundredth, which is that first 7, and if we look to the number to the right, it's a 7. So the 7 that we are rounding off to the hundredth will become an 8, because 7 is 5 or bigger. So there's our answer, 124,68, and the answer is D. This takes a bit of practice, but the key to getting this correct is being able to identify what each number represents. Thousands, hundreds, that one's actually hundreds, this one's 10,000s. Okay, you see I'm getting a little bit confused. This one, 6 is tenths, then we've got hundreds, then we've got thousands, and then 10,000s. You need to know that. It is in your note. It's the first section. They show you which unit represents what, which number represents which unit. So this one is 124.68 when rounded to the nearest hundredth. Right, round 3506 to the nearest 10. So we got units, ones, then we got tens, hundreds, and thousands. So they say to the nearest 10, and to the right of the naught is 6, which is 5 or bigger, and the naught will become 1 and the 6 will become 0. So it's 3,510. These are easy marks if you've practiced it a bit. The answer here is B. Number 4. Now we got conversions. You need to know how many grams in a kilogram, how many milliliters in a liter. The examiner sticks to the more common conversions, but you need to know how many grams in a kilogram, how many milliliters in a liter, how many centimeters in a meter, how many meters in a kilometer. In order to do this, you need to know those conversions. So it says convert 64,750 grams to kilograms, and all we need to know, because there are 1,000 grams in a kilogram, we take the grams, 64,750, and we divide by 1,000, and we get 64,75 kilograms, which is A. Next one, convert 15,000 milliliters to liters. There are 1,000 milliliters in a liter, and we want to convert it to liters. So we divide by 1,000. 15,000 divided by 1,000 is equal to 15 liters, and the answer is A. Next one, convert 21.1 kilometers to meters. 1,000 meters in a kilometer. We take the kilometers and multiply by 1,000 in order to get the meters. 21,100 meters, and the answer is D. Next one. Right, we're moving on to break even, and in this question here it says I've put in the formula. You need to know these formulas. Go and have a look at my videos on break-even calculations. So how do we calculate the number of units where we break even, where income is equal to expenses? How many units need to be produced and sold for the company to break even? So the break-even number of units, see, you need to know these formulas and how to calculate the different parts of the formula. So break-even units is equal to the fixed cost divided by the contribution per unit. And if we look at this table here, we got unit prices, and we got sales and variable costs. Contribution per unit, I'm going to say this again, contribution per unit is equal to the selling price per unit minus the variable cost per unit. And the fixed costs in this case here, they actually give us the fixed costs, which is 2250. So there we go. The fixed cost is 2250. So we've got the fixed cost 2250. It's actually 2,250,000. Now we want the contribution per unit. So we got the fixed cost 2,250,000. The contribution per unit is equal to the sales price per unit. Now how did I get the sales price per unit of 500? I said 4.5 million divided by the number of units sold. There it is, 4.5 million, which is the rand value of the sales, divided by the number of units sold, would equal 500. Then I go and take off the variable cost per unit of 200, which was given. So 500 minus 200 is equal to 300. And now we have the contribution per unit. The contribution per unit is 500 minus 200, which is 300. How did I calculate that 500? I said 4.5 million divided by 9,000. There it is. 4.5 million divided by 9,000 gives you 500. Minus 200 is equal to 300. That is the contribution per unit. And then we go and say the fixed cost, which is given 2.250 million divided by the contribution per unit is equal to 7,500 units. So the break-even units, according to the information given, is B, 7,500 units. The break-even is difficult to calculate, but if you know your formulas, you will be able to do it. One thing that comes up often is the contribution per unit, which is the selling price of a unit minus the variable cost price of a unit. In this case here, I need to rub this out. It was 500 minus 200, which would have given you the contribution per unit. How did I get that 500? I said 4.5 million divided by the number of units sold, 9,000, gives me 500. Minus 200, which is the variable cost per unit, it's given to us, is equal to 300. And then the fixed cost was given. And we get 7,500 units. At 7,500 units, the business breaks even. There we go. Watch that again. Right, the next one, it says from table 1, calculate the break-even sales. Now the fixed cost was given to us, 2.250 and 3 noughts. The price was 500 per unit. There it is. We've already calculated that in the previous example. 4.5 million divided by 9,000, and that is equal to 500. The cost price per unit minus 200 is equal to 300. That's the contribution per unit. The contribution per unit is equal to 300. And then we've got, once again, I'm doing some calculations from the previous example. You've got the fixed cost divided by the contribution per unit multiplied by the selling price multiplied by 500. So you got the fixed cost divided by the contribution per unit, and that was actually in the previous example, I think it was 7,500. So you could have taken the answer from number 7 and then you simply multiply by the selling price per unit of 500 in order to get the sales figure of the break even. And the answer is, there it is, break even sales is equal to the fixed cost, which is given, divided by the contribution per unit. Remember that there. That gave us the break-even units calculated in the previous example, multiplied by the price, which was 500, the selling price, and that is going to give us the break-even sales value in rands. It says calculate the break-even sales in rands. So we got the break-even units calculated in the previous example. I did it again in these workings, multiplied by the selling price per unit, which was 500, and that gives us 3,750,000. Right, next example, it says calculate the contribution ratio. So it's the total contribution in rands divided by the sales in rands. So the total contribution in rands, what we've been calculating in the previous examples, was the contribution per unit. Now what we're doing is we're calculating the total contribution in rands divided by the sales in rands, and to get a percentage we multiply by 100. Now if you remember correctly, in the previous example, the total contribution per unit was 300. Now what they want is they want the total contribution for all the units. So what we need to do is, we've got the selling price or the sales in rands, 9 million multiplied by 500 is 4.5 million. We need to say 9,000, because there were 9,000 units, multiplied by 200, and we need to take it away from the 4.5 million sales. So it's like sales minus cost of sales. And yeah, we've got here the sales minus the variable cost of all the products, which is 9,000 multiplied by the variable cost per unit, 200, and the formula then says you need to divide by sales in rands, which is sales in rands, 4.5 million. So 4.5 million minus the 9,000 times by 200 is equal to, now this here is the total contribution in rands, 2.7 million, and then it says divide by the sales in rands, which is 4.5 million, there's the sales in rands, and multiply by 100. So let me go through that again. I first calculated the total contribution in rands. So it was 9 million multiplied by 500 is 4.5 million. Then I needed to get what is the variable cost, the total variable cost, which was 9,000 multiplied by 200. There it is. And the total sales minus the total variable cost gives me the total contribution in rands. And then we need to divide by the sales in rands and multiply by 100. And you will see that is A, it equals to 60%. You might need to go through this again to understand it properly, but the total contribution in rands is the total sales minus the total variable cost divided by sales in rands, which is given, multiplied by 100, will give you the contribution ratio. Next one. It says here, from table 2, calculate the margin of safety in units. And what we need to, the margin of safety is sales in units minus the break even in units. How did we calculate break even in units? We said fixed cost divided by the contribution per unit. Remember, how do you calculate contribution per unit? You take the sales price per unit minus the variable cost per unit. So let's have a look what we got here. We first have to do, we need to calculate the break even in units. So break even units is the fixed cost of, there it is, 1.8 million divided by the contribution per unit. The contribution per unit is 7,000. If I said 4 million divided by 1,000, I'm going to get 4,000. So 7,000 minus 4,000 is equal to 3,000. And if I take the fixed cost, divide by the contribution per unit, we're going to get 600. And 600 is the break-even units. But in order to calculate in units the margin of safety, we say the sales in units, which is 1,000, minus the break-even in units, which we just calculated, is 600, and 1,000 minus 600 is equal to 400. So the margin of safety is 400 units. But the first thing, we got this formula, margin of safety. It's sales unit number minus the break-even unit number. The first thing we need to calculate is the break-even unit number. And the break-even unit number is the fixed cost divided by the contribution per unit, which is per unit selling price minus per unit variable cost. 7,000 minus 4,000. This takes practice, as you know. So in this case here, the margin of safety is 400 units. The margin of safety is 400 units. And normally what happens in a test after that, they ask what is the rand value of the margin of safety if we got 400 units. Right, let's move on. So there we go. We have now got the margin of safety calculated in the previous question was 400. So to calculate the margin of safety in rands, we say 400 times by the selling price, unit price, is 2.8 million. So the margin of safety, there we go, the margin of safety in rands was the units that need to be sold to be safe times by the selling price per unit, and there it is. Right, now we get on to interest. It's very important in this section that you know which formulas to use. You will be provided with a formula sheet, but it doesn't help if you don't know which formulas to use. And once again, you need to practice to know which formulas to use. Only you can do that. You'll get simple interest formulas and compound interest formulas, and you will also know how to use, you need to know how to use your calculator. So let's start with simple interest. Calculate the simple interest on an investment of 19,500 for 20 months at 5%. You may have different methods, but if you practice your methods and you're getting the correct answers, stick with it. Now what I've done is I've said 19,500 times by 5% times by 20 over 12, which is 20 months. The 20 over 12 will give me, if I go and punch it into my calculator, I'll do it quickly, 20 divide by 12, which gives me 1,6666 years. So the 20 over 12 is going to give me the right decimal for the time invested, because 20 months is actually 1.66667 years. You use your methods. 19,500 times by 5% times by 20 over 12 is equal to 1625. So the answer is B. The simple interest on this investment is 1625. Now often questions follow on in this section and the break even. Let's see what happens now. It says calculate the simple interest on an investment of 19,000 for 20 months. That was the previous question. Then it says from that question calculate the value of the investment at the end of the term. So from the previous question, the interest was 1625. What was invested? 19,500. So what is the value of the investment at the end of the 20 months? 21,125, and the answer is D. So the first question was calculate the interest, and then the next one is what is the value of the investment with the interest at the end of the 20 months. So 21,125. Next question. It says a loan of 7,000 Rand was taken out at a simple interest rate of 9% per annum for 180 days. What amount must be paid back at the end of the term? Assume that the year is a normal year. So a loan was taken out, simple interest, 9% per annum, 180 days. The loan was 7,000 times by 9% times by 180 over 365 is going to give me the interest. And what amount needs to be paid back? The original loan plus the interest gives me a total of 73,1068. Right, a normal year, 365 days. How many days? 180. How many days in a leap year? 366. Normal year, 365. The answer here is 7310. So what is paid back at the end of the term? The original amount of 7,000 plus the interest. Right, next question. It says calculate how much an individual needs to invest today to achieve 30,000 in 4 years at a simple interest rate. What must a person invest today, the principal amount, the present value, the principal amount, to achieve, A stands for a future value of 30,000 at an interest rate of 7% for 4 years. And this formula, you must know, is the formula to calculate the present value using simple interest when we're given a future value. And if we put in the numbers, the future value is 30,000. We use the formula 1 plus the interest rate of 7%. You convert that to a decimal, 0.07 multiplied by 4 years is equal to 30,000 divided by 1 plus 0.28. You need to practice using your calculator here. The question was how much money needs to be invested today in order to get 30,000 in 4 years time, and you got a formula for it. Know which one to pick for simple interest and which one to pick for compound interest. How much needs to be invested today to get 30,000 in the future? Simple interest at 7%. And the answer is 23,437. Right, we get in there. An investment was made at a bank for 2.5 years at a simple interest rate of 5% per annum. The interest received on this investment was 1,750. How much money was invested? So now what we don't have the future value amount. We are given the interest amount. So this is still simple interest. In the previous example, there was an A on top, but now we're given the interest amount. So you selecting the formula P is equal to I over R times by T, and you're given the 1,750. And you're given the interest rate, and for the number of years, 2.5. It's all about knowing which formula to select. In this case here, we're given the interest amount. The numerator will be I, and you're taking the simple interest formula. The answer is A, 14,000. Next one. A loan of 350,000 was obtained from a bank. What amount must be paid back to the bank after 10 years? Compound interest. A is the future value. What amount must get paid back to the bank after 10 years? Calculate the future value when 350,000 is invested at 8.25% for 10 years. So there's the formula. A is equal to, and this is compound interest, P, 1 plus R, time period, 10 years. So the number is 10. 350,000, you know how to use your calculator. You punch this into your calculator, 1,0825, because it was 1 plus R, 1 plus the interest rate. 8.25 as a decimal is 0,0825 plus the 1. Number of periods, 10 years. You go and put that into your calculator. Second function, you pick that little button, X, Y. Might be different on your calculator, but X, Y. 10, punch in 10, and then you push equals, multiplied by the 350,000. And there's your answer. What amount must be paid back? Quite a lot. Compound interest is expensive if you lend money, and it's compounded on in this case it was an annual basis. Could be compounded monthly. So after 10 years you're going to pay a lot of money back. Right, next one. An amount of 170,000 was invested for 15 years at compound interest rate, 8% per annum. What is the value of the investment at the end of the term? Let's have a look. Right, A is future value. Amount invested, quite easy. compound interest, 1 plus R, time period 15 years. Once again, you say 1,08, select that XY function, type in 15 and push equals, times by 170,000, and that is the value at the end of the term, 539,268. You invested 170,000 for 15 years, 8% per annum. It's compounded nicely. That's what it's worth at the end of the 15 years. Amazing. That 170,000 grew that much. They might ask you, let's see in the next question, how much did it grow by? Yes. It says from the previous question, calculate how much interest was earned. That's A, which is the future value, which we just calculated, minus what was invested, will give us the interest that is earned. Quite easy. And there's the answer, D. Right, number 20. How much money was invested if after 8 years at a compound interest rate of 7.5% per annum, the investment was worth 125,000? So we got P. What is the amount invested if it's worth 125,000 in the future after 8 years at 7.5%? So how much was invested right in the beginning? Okay, once again, you use your calculator there. You might have to write that down. Say 125,000 divide by, recall your memory on the calculator, and the answer is D, 70,087,78. Thumbs up. I hope this has or is going to help you just a bit with your preparation for your RBA exam. You need to watch the break-even analysis calculation videos on my channel. You can watch test 1 for revision. Here's test 2 for a revision. You still need to do units 5 and 6, but hopefully this will help you. Right, all the best for your exam. Cheers, bye.